Pressure. As shown in figure 2.9, pressure may be expressed in different ways depending on the unit area selected. Normally, however, the unit area of a square inch and the expression of pressures in pounds per square inch, PSI, are preferred. In metric units, pressure is generally expressed in kilopascals, kPa. In the operation of a water treatment system, you will primarily be concerned with the pressures exerted by water. Water pressures are directly related to the height or depth of the water. Suppose, for example, you have a container 1 foot by 1 foot by 1 foot, a cubic foot container that is filled with water. What is the pressure on the square foot bottom of the container? Pressure in this case is expressed in pounds per unit area. In this case, since the density of water is 62.4 pounds per square foot, the force of the water pushing down on the square foot surface area is 62.4 pounds. Figure 2.10. From this information, the pressure in pounds per square inch can also be determined. Convert pounds per square foot to pounds per square inch, PSI. 62.4 pounds per square foot equals 62.4 pounds over 1 foot by 1 foot, which equals 62.4 pounds over 12 inches by 12 inches, which equals 62.4 pounds per 144 square inches, which equals 0.433 pounds per square inch, which equals 0.433 psi. This means that a foot-high column of water over a square inch surface area weighs 0.433 pounds, resulting in a pressure of 0.433 psi. Figure 2.11. The factor 0.433 allows you to convert from pressure measured in feet of water to pressure measured in pounds per square inch, as shown later in this section. A conversion factor can also be developed for converting from pounds per square inch into feet. Since 1 foot is equivalent to 0.433 psi, set up a ratio to determine how many feet of water are equivalent to 1 psi. That is, how many feet high a water column must be to create a pressure of 1 psi. We have 1 foot over 0.433 psi equals x feet over 1 psi. We then solve for the unknown value. 1 by 1 over 0.433 equals x, or 2.31 feet equals x. Therefore, 1 psi is equivalent to the pressure created by a column of water 2.31 feet high. Figure 212. Since the density of water is assumed to be constant, 62.4 pounds per cubic foot in most hydraulic calculations, the height of the water is the most important factor in determining pressures. It is the height of the water that determines the pressure over the square inch area. Pressure measured in terms of the height of water in meters or feet is referred to as head. As long as the height of the water stays the same, changing the shape of the container does not change the pressure at the bottom or any other level in the container. For example, see figure 213. Each of the container is filled with water to the same height. Therefore, the pressures against the bottoms of the containers are the same, and the pressure at any depth in one container is the same as the pressure at the same depth in either of the other containers. In water system operation, the shape of the container can help to maintain a usable volume of water at higher pressures. For example, suppose you have an elevated storage tank and a standpipe that contain equal amounts of water. When the water levels are the same, the pressures at the bottom of the tanks are the same. See figure 214a. However, if half of the water is withdrawn from each tank, the pressure at the bottom of the elevated tank will be greater than the pressure at the bottom of the standpipe. Figure 214b. Because of the direct relationship between the pressure in pounds per square inch at any point in water and the height in feet of water above that point, pressure can be measured either in pounds per square inch or in feet of water, called head. When the water pressure in a main or in a container is measured by a gauge, the pressure is referred to as gauge pressure. If measured in pounds per square inch, the gauge pressure is expressed as pounds per square inch gauge, PSIG. The gauge pressure is not the total pressure within the main. Gauge pressure does not show the pressure of the atmosphere, which is equal to approximately 14.7 psi at sea level. Because atmospheric pressure is exerted everywhere against the outside of the main as well as the inside, for instance, it can generally be neglected in water system calculations. However, for certain calculations, the total or absolute pressure must be known. The absolute pressure, expressed as pounds per square inch, absolute PSIA, is obtained by adding the gauge and atmospheric pressures. For example, in a main under 50 psi gauge pressure, the absolute pressure would be 50 psig plus 14.7 psi equals 64.7 psia. A line under a partial vacuum with a gauge pressure of -2 would have an absolute pressure of 14.7 psi plus -2 psig, which equals 12.7 psia. Figure 2.15. Pressure gauges can also be calibrated in feet of head. A pressure gauge reading of 14 feet of head, for example, means that the pressure is equivalent to the pressure exerted by a column of water 14 feet high. The equations that relate gauge pressure in pounds per square inch to pressure in feet of head are given below. In this book, conversions from one term to another will use the first equation only, such that 1 psig equals 2.31 feet head, and 1 feet head equals 0.433 psig. The following examples illustrate conversions from feet of head to pounds per square inch gauge and from pounds per square inch gauge to feet of head. The method used is similar to the conversion approach. Box method. Example 39. Convert a gauge pressure of 14 feet to pounds per square inch gauge. 1 psig equals 2.31 feet of head. Using the diagram, in moving from feet of head to pounds per square inch gauge, you are moving from a larger box to a smaller box. Therefore, you should divide by 2.31. 14 feet divided by 2.31 feet per psig equals 6.06 psig. Example 40. A head of 250 feet of water is equivalent to what pressure in pounds per square inch gauge? 1 psig equals 2.31 feet head. When you move from a larger box to a smaller box, division by 2.31 is indicated. 250 feet over 2.31 feet per psig equals 108.23 psig. Example 41. A pressure of 210 kilopascals gauge is equivalent to how many meters of head? When you move from a smaller box to a larger box, multiplication by 0.1019 is indicated. 210 kilopascal gauge by 0.1019 meters over kilopascals, which equals 21.4 meters. Example 42. What would the pounds per square inch gauge pressure readings be at points A and B in the diagram in figure 216? In each case, the conversion is from feet of head to pressure in pounds per square inch gauge. Therefore, when you move from a larger box to a smaller box, division by 2.31 is indicated. Pressure at A equals 200 feet per 2.31 foot over psig, which equals 86.58 psig. Pressure at B equals 80 feet over 2.31 feet per psig, which equals 34.63 psig.